Hello, Algebra Honors kids. We're doing Unit 2, Lesson 2. We're going to do some word problems today. This is your Standards 2.2. So you're going to be able, by the end of this, hopefully to create a linear equation and be able to solve for it, given a real-world scenario. All right, in these word problems, there's a couple that are like super easy, pretty straightforward. And then I hit you with some more challenging ones on the back page. So it's a formula that you've used, maybe a real basic one that you used way back when, but it's definitely some twists. So these are not real easy word problems. And that's actually why I'm kind of glad that I'm recording it, because you can go back and kind of review. It's the rate times time problems. It's the last two. So when you go to do your homework for this, I know that there may be some difficulty. So that's one thing that I keep in mind. And then when we meet up again in class the next day, we're going to be going over those. But you got to try them on your own first, okay? So word problems. There are 5 steps that I like you to have. You have to first clearly define the quantities involved. So think let statements. So let x equal, let y equal, whatever. We're going to use X or W or M. Depending on the scenario, I like to actually use the letter that is in direct reference to the context of the problem. So you'll see what I mean. Then the second one, use your let statements to write an expression for quantities that you are interested in. And that sometimes is with the example 2. I'll show you that there might actually be two let statements. Okay, we have to write a let W equal, and then let W equal something else. 3, carefully translate the information that you are told into an equation. So you're going to set up an equation, 4, you're going to solve it, and then 5, you better check and make sure. So when I get an answer, like when I solve the equation, I get an answer, that doesn't mean that I've answered the question. So you always got to go back and say, did I answer the question? That's the step 5. Okay, let's start with Rosita. Read this problem. I got to grab a Kleenex. And I can't pause it, so you read. I'll be right back. Okay. If I sneeze or I sniffle, I have allergies. Okay, so you've read this problem. So we need to know how many minutes can her telephone call last. So I'm going to say let M equal the minutes that she talks. Okay, or the minutes of the phone call. One of the two. All right. Now, it says that she has, and I'm going to give you a minute. I'm going to give you a second now to try and come up with, okay, so that was the first one. Clearly define the quantities involved. Use your let statements to write out an expression. We don't have any more expressions for this one. But we do, for 3, you're going to create an equation. So take a minute and create an equation. And then don't solve yet. Create the equation first and then we'll talk. Because there's a trick in this first one. Okay, so your trick is right here. 75 cents for the first minute. The first minute is included in that 75 cents. So you are going to set up, and you're paying a total of $2.15. So you're going to set it up and say, okay, I have to pay 75 cents, right, for the first minute, plus 14 cents for every minute after. So you don't want to say 0.14 times M, because that M represents all the minutes we talked, right? We have a minute in the 75. So I have to do M minus 1, because that minus 1 is the first minute, which is included in the 75 cents, okay? And then all that totals $2.15, okay? So That's a little bit different than maybe some of you were thinking, which means I've got to distribute. Because now I'm going to solve for m. Okay, take a minute. I distributed it for you so you can see that double distribution, or the distributed property into, not double distribution, the distributed property into the m minus 1. So combine like terms and solve for m. When you are done, you should have gotten m is equal to 11. So that means that she talked for 11 minutes. Okay? And remember, go back and check to make sure you answered the question. How many minutes can her telephone call last? 11 minutes. So she can talk for 11 minutes because she's got $2.15. Okay? You guys don't have to worry about that as much anymore because we have unlimited, but back in the day, with the phone booths, it was totally different. I don't even know what that is now. But there it is. Okay. Example 2, I'm going to let you try this. You've done a lot of these. So go back and look at the steps. I'm going to tell you that I like the variable to represent the information, the context of the problem. So I will say that you're going to start with a W because it's width. So take a minute and read. And set it up. I'll give you a couple minutes. All right. So it says, what is the length of the rectangle? And notice they compare the length to the width. So that's why I said we got to start with let W equal width. All right. Now, clearly define the quantities involved, the let statements. The second step, use your let statements to write out expressions for quantities that you are interested in. So we need more than the width. We also need the length. And this says the length of the rectangle is 6 inches more, which is plus, than its width. So we take the width and we add 6 to equal the length. Now, in those steps that I gave you for word problems, I didn't say anything about drawing a picture, but sometimes it's actually very helpful to just draw a picture so that you can visualize, okay? Now it says the perimeter of the rectangle is 2 feet. Okay, now there's also another twist in here, which hopefully some of you picked up on. That is inches, that is feet. They have to be the same, right? So I clearly defined my variables in terms of inches. I want to change this in terms of inches as well, okay? So for every 1 foot, we have 12 inches. So this equals, right, 2 times 12 is 24 inches. All right, so make sure that conversion, because the measurement's got to be the same. And they throw those in to a lot of problems in all of your readings over the next couple of years, in Algebra 1, Algebra 2, and I've seen it in Algebra 3, where it's real slight. They give you something where they're talking about measurement or units or something, those units have to be the same. So you got to start picking up on that. All right, so the perimeter of the rectangle is 2 feet, which is now 24 inches. What is the length of the rectangle? So there's a formula there, perimeter. So remember, perimeter is where you double, you take 2 of the W plus 6s, 2 of the W's, and they total 24, right? Or add all sides, right? That's a shortcut. I could take W plus 6 plus W plus 6 plus W plus W. Same thing. Solve. Go, 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 go. You should have gotten W equals 3 inches. All right, now, come back here. And it says, carefully translate the information you are holding into an equation. We did. Solve the equation. We did. 5, check the reasonableness of your answer, which there's a couple of things there. It could be that you end up with negative solutions, which are not true, right? When you're measuring, if you came up with a negative inches, there's something wrong. That's not reasonable for this scenario because you can't have negative inches, you can't have negative measurement. But the other piece too is it says, what is the length of the rectangle? I found the width. So I have to say the length is, remember, the length was 6 more than the width. So the length is 9 inches. That's why that last step is actually really important. Okay? All right, flip it. I'm going to let you, I'm going to go get another Kleenex. My nose is just crazy. Crazy, crazy, crazy. It will not stop. It's all because of the allergies. I got lots of allergies this time of the year. All right, so I want you to take example 3. I'm going to give you a few minutes. I want you to try it, and then I'm going to come back and I'll throw it on the board for you, okay? So pause, so you don't have to hear me blow my nose. Pause and try it, okay? I'll be right back. Okay, hopefully you have paused and unpaused, and you have something like what I'm about to do. So I had B equals bags, because remember I said I wanted you to kind of keep the variables in the context of the problem. So I know when I look at B, I'm thinking bags. That's what I'm trying to solve for, how many bags. One company is 1,200 plus 9B. The other company is 1,500 plus 7B. I set them equal because this is how many bags will each company need to manufacture in order for the expenses to be the same price. And when I solved this, I should not have negatives, right? That's not reasonable. I had 150 bags. Okay. All right. So I promised you a couple of ones that were a little bit more challenging. So this is going to step it up a notch. All right. We've got rate times time equals distance is the formula that you're going to focus on for these next 2 problems. So think about this. When I go 50 miles per hour, that's a rate, okay? How fast you drive in the car, that's how fast it is, right? 50 miles per 1 hour. So think about that. If I drive 1 hour at that rate, I go 50 miles, okay? So that's your rate. Your time is how long you're driving that measurement or that rate for. So let's say I drive for 2 hours at 50 miles per hour. I'm on the throughway. 50 times 2 means that I end up with a distance of 100 miles. Okay, that's what I did. I drove 2 hours at 50 miles per hour. I end up with 100 miles. So that's your distance. When you see these problems, you should be able to recognize them pretty quick based on the 2 that I'm going to give you. And then on your homework, I'll pull it out. Let me pull it out right now and look at it so I don't forget. And then I put your homework packet. Hold on, let me grab it. Nope, I probably left it. Okay, so that's great. Let me do this really quick. Because I want you to recognize where the homework questions are. So bear with me just a minute. In the middle of the video. I want you to see that when you do those homework questions, that anything where they're talking about, it starts with number 9, anything that they're talking about cars or freight trains or another car where they're talking about miles per hour. So 9, 10, and 11 of your homework are going to be these types of problems. Okay, so mark that. 9, 10, and 11. Oops, did I go too far? All right, so you're going to use that rate times time equals distance. Just like on the previous page, right, we use perimeter formula. Same deal, okay? When you see these, you're going to use this formula. All right, so example 4. We've got 2 jets that leave Dallas at the same time. Okay, they leave at the same time, so their time is going to be exactly the same and fly in opposite directions. So here's Dallas. One plane goes this direction, one plane goes this one. We're going to call this jet 1 and this jet 2. Okay? One is flying west, 50 miles per hour faster than the other. So we don't know how fast they're flying. But then it says after 2 hours, okay, so they give us 2 hours is time. So this right here is my time. The jets are 2,500 miles apart. That's distance, isn't it? All right, now in order to do these successfully, what I have found is you really need to set up a chart. So I want you, for each one of these problems, to have a rate times time equals distance chart on your paper, okay? And we're going to call this jet 1, and we're going to call this jet 2, right? So jet 1, we don't know the rates, do we? So it says 1 is flying west 50 miles faster than the other. So jet 1 is flying west, right? That's based on my example here. West is to the left and east is to the right. If I'm looking at north, south, west, east, east, west. So I'm going to say, it says 1 flying faster. I don't know any of the rates. So I'm going to say R is going to be the rate for jet 2. And then the one going west, jet 1, is 50 miles per hour faster. So R plus 50 is the rate for jet 1. Okay, so I'm going to come down here and in my chart, where it says jet 1, I'm going to do R plus 50. You know what, let me move this a little bit. Make this just a little bit bigger for you. Jet 1, sure the most units. Jet 1, jet 2. Okay, so jet 1 is R plus 50 and jet 2 is R, right? Because the one going west, our jet 1, our diagram, is 50 faster than jet 2. Okay, now we know time. We know time is 2. Okay, and then it says the jets are 2,500 miles apart. That does not mean that each of them separately are 2,500 miles. That means total, their total distance away from each other, total distance is 2,500. Okay? So how am I going to figure out this part up here, the distance? Well, use the formula for this, okay? Rate times time. So rate times time equals distance. So you're going to do 2, let me do it in the right order. Rate times time. And down below for jet, do rate times time, okay? The 2 rates and the times together total 2,500. Does that make sense to you? So I'm going to come back up to this picture up here, right? In this jet, going in this direction, I would take his rate times time. In this jet, going in this direction, take his rate times time, is there two distances separately, but together, all together, they're a total distance away of 2,500. So anytime you hear anything about like two objects that are going away from each other in one of these problems, it's safe to say that it's their distances added up to total that, whatever that distance, that total distance they gave you. So I'm going to distribute here, and I'm going to go 2r plus 100 plus this 2r equals 2,500. So this represents jet 1's total distance. This one represents jet 2 total distance. And then together, they're 2,500 miles apart from each other. And I got a formula. So I want you to take a minute and solve. So 2r and 2r is 4r. I'm going to subtract that 100. And I've got 2,400. And I'm going to divide by 4. And I got 600. Now, it says find the speed of each jet. So it would make sense that it's 600 miles per hour because they're jets. So be careful. What I determined though, right, was that R is jet 2. So 600 miles per hour for jet 2. And then jet 1 was 50 miles per hour faster. Is jet 1 is 50 miles per hour faster. Now I could go back here and test it. So let's go back to jet 1. And if we said this was 650 miles, right, per hour, times 2, that would give me 1,300 miles, 1,300 miles. So 650 times 2 hours, that one jet alone is now 1,300 miles away from Dallas. The first jet is 600 miles per hour times 2, right, at times 2 hours is 1,200 miles per hour away from Dallas. Together, the 1,300, the 1,300, and the 1,200 total 2,500. So that's how I calculated it. Okay, now there's going to be another scenario where you're actually, for these rate times time equals distance, like I said, there's two scenarios. There's one where they're going away from each other, and you'll get a total distance typically, or something that you have to calculate like that. Then there's this one, example 5, where the trains leave at the same time, and one maybe leaves before the other, and then you have to find the point where they catch up, where their distances will be the same, okay? So let's look at this one. A train leaves a train station at 1 p.m. It travels at an average rate of 72 miles per hour. Okay, so that is a rate. A high-speed train leaves the same station an hour later. It travels at an average rate of, okay, there's another rate, of 90 miles per hour. That's the faster one. It leaves later, but it's faster. The second train follows the same route as the first train on a track parallel to the first. Thankfully, they're parallel. They're behind, not be good, because he's eventually going to catch up and run into them. Okay? In how many hours will the second train catch up to the first train? Now, I have a lot of kids that say, but they gave me a time. They actually didn't give you time. They gave you a time that they left. They didn't give you how long they're on the track for. That's totally different. Okay? I don't know if we're going to do this. So we're going to do this little fancy rate times time equals distance, right? And I'm going to say train 1 and train 2, and I'm going to put everything together. So we need to know, it says how many hours. That means let t equal time for train 1. So let's look at train 1. It travels at an average rate of 72 miles per hour. So I know that the rate is 72 miles per hour, and I don't know how long it's on the track for. But I do know if I do rate times time, and I keep it, because I don't know the distance either. I don't know, they didn't give me any distance. So do not put a D in there. I don't want two variables. Follow the formula. Rate times time, 72 times t, is 72t, okay? I'm using those rate times time to diagnose the distance, to give me the distance. I don't want a d variable. I didn't put a d variable in here. Don't put another variable. You're only working in one variable. That's why they call them linear word problems, one variable. Okay, the second train follows the same route as the first train on a parallel track to the first, right? And that train leaves an hour later. So whatever the first train travels, the second train is an hour later. So let's say the first train's on the track for 5 hours. Okay, the first train's on the track for 5 hours. That means the second train's only on the track for 4 hours. Because it goes faster, it's going to catch up. So you're going to do t minus 1 is the time for train 2. So t minus 1 is the time for train 2. And train 2 also goes faster. So that makes sense that eventually they'll catch up. The faster you drive or the faster the train goes, right, the quicker it'll get there. That means the time will be less. And again, I'm going to talk in terms of the distance as the rate times the time. Okay? Rate times time. So 90 times parentheses t minus 1. Don't forget the parentheses. If you don't do the parentheses, it messes it up, right? Because you're not going to be distributing to that negative 1. Okay, and how many hours will the second train catch up to the first? This is when the distance of both trains, the distance of both, are equal, because where they catch up to each other is where that distance is the same. So literally, I'm just going to take their distances and set them equal. Okay? So go. Solve for t. Take a minute and solve for t for me. Okay. So I distribute. Right, and then I'm going to subtract that 90t. And notice they're both negative, right? So I got a 72 minus 90 is negative 18. And I got a negative 90. That's okay. I know you're thinking, well, time's not going to be negative, but when I do a negative divided by a negative, I end up with a positive. So don't worry about that until you get to the very end. If it's negative at the end, then there's a problem, right? Okay, so in how many hours will the second train catch up to the first train? I got to go to the second train. This is where, again, that last step when you do word problems, make sure you've answered the question correctly. Okay, so remember the second train has been on for less hours. And it says how many hours will the second train catch up? So that means that it will catch up in 4 hours. The second train is on the track for 4 hours for the second train. Okay? All right, that was a lot today. I know it wasn't your typical word problems. You're used to them being a little bit more straightforward, and so now we're going to twist it up a little bit more. So I want you to try all those word problems on that sheet, and I recognize that you're going to have some difficulty. So at the very least, set up some variables and try and set up an equation. And if you feel like it's really off, then just leave it. But I want you to try. I'm going to walk around and check when you guys come in. Next time I see you, we'll be live. Yay! So I want you to try all those problems, okay? All right, thanks for hanging with me. I know this was a long one. Okay, take care.